So the following is our data structures and algorithms project, and the topic we have chosen for our presentation today is bookstore optimization using our two chosen data structures, array and linked list. So we have decided to implement certain traversal insertion operations on an online bookstore that we have created using some functional code using both an array and a linked list. And we essentially plan to check which data structure will prove to be much more useful in comparison to the others after comparing a few key performance metrics. We now arrive at the introduction for this specific topic. So, as written here, we undertake the task of efficiently managing an online bookstore, focusing on insertion, search, deletion, and traversal operations. Now, Bikash will tell us a little bit more about the problem statement.
The problem statement for this problem of the data structure is the efficient management of online bookstore. This project aims to compare the performance of arrays and linked list data structure while performing different tasks of insertion, deletion operations with the ultimate goal of selecting the optimal data structure to enhance the operational efficiency.
So now we'll be talking about array. So in this project, array serves as the foundational data structure for efficient book inventory management. Each array element meticulously represents a book, facilitating swift access to specific tiles. The intricate choreography of insertion and deletion uh, orchestrated through precise adjustments to array elements. So now let's see how the array is implemented in our bookstore management system. So this code serves as an online bookstore management system that relies on an array data structure to streamline book inventory management. Each array element corresponds to an individual book, simplifying data organization and access. With dynamic array expansion, the code ensures the array size adopts seamlessly as the inventory grows, optimizing memory usage and accommodating a varying number of books. The array structure offers direct access to specific book details, facilitating quick lookups and data manipulation. Moreover, memory management is handled with precision as the code frees allocated memory upon program exit, prevention memory leaks. In essence, this implementation strikes a balance between simplicity and efficiency, make it making it an ideal choice for small to medium-sized online bookstores. Its utilization of arrays underscores the importance of practical resource management in software development while providing a versatile foundation for future enhancement and scalability in the dynamic world of online book retails. So now let's see the time and space complexity of the following code. So the space complexity of the code depends on the number of books. So it would be O of n, and the time complexities are given for every function. That is, for adding a book, it will be O of 1. For displaying a book, it will be O of n, as n implies the number of books. And when exiting the program, it will be O of 1. So now I would like my friend ARYAMAN to tell us about linked list, how linked list is implemented in this system.
So now we will look at the code implementation for linked list data structure in this particular bookstore. Now, linked lists, as we know, are very handy and very quintessential, very crucial data structures, which provide the very superior advantage of contiguous memory allocation. So you can connect 2 points to each other, regardless of where they're spaced, right? So, in a sense, you can make the argument that it is much more efficient than an array. So now we will take a brief glimpse at this specific code that has been given here for this linked list. So this specific C program is designed to manage an online bookstore using a linked list data structure, as discussed previously. It begins with the definition of a book structure, holds information about each book, including various information which is given in the form of variables like ID, title, author, price, etc. A global variable called head serves as the starting point of the linked list, which is initially set to null. This is a head pointer, one of the more important parts of a linked list, which indicates an empty bookstore since the head pointer is null and it has the count of books, right? Moving on. This program provides two main functions. The add book function allows the addition of new books to the bookstore. It dynamically allocates memory for each book, sets its attributes, and links it to the existing list. Malloc, as we know, dynamic memory allocation is a very crucial part of linked lists, which it cannot do without. In C, we use malloc, whereas in C++, we might use something like new. Anyway, moving on. The display books function, on the other hand, displays all the book details in the bookstore, iterating through the linked list. The program's menu-driven interface, found in the main function, allows users to add books, view the catalog, and exit the program. So, being multifunctional in a sense. Users can input book details for addition and can choose to display the catalog of books. To prevent memory leaks, the program then deallocates memory, which is always a very good practice when we're working with linked lists, since pointers do take up quite some memory, right? So overall, this code exemplifies a basic online bookstore management system utilizing a linked list and dynamic memory allocation, both of which are very important here. And that pretty much sums up this code for linked lists. Moving on. Please move to the next slide. Here we have the time. Now we come to comparison for array versus LL. But before that, taking a brief glimpse at the type complexity here. So adding a book, one. O of one, as we can add it anywhere. It doesn't matter where it is in the memory, right? You don't have to resize anything as in an array using realop or whatever. This makes it quite a little bit more useful in comparison to arrays, which we will see again later in the conclusion. Displaying books, the time complexity will, as a matter of fact, be O of n since you have to traverse the entire linked list. That makes quite a little bit of sense. Exiting the program, the time complexity will be O of n again. And the space complexity here is O of n, which is pretty self-explanatory in itself. Now we have our friend BIKASH explaining the comparison between linked list and array, seeing who the winner is here.
So now, while comparing both array and data structure and linked list data structure, it depends on specific requirements, which it depends on while comparing the both data structures. So the key matrices for the comparison we have taken for our bookstore management is memory uses, insertion time, search and retrieval, and deletion time. At first, in the insertion in array has given the time complexity of O of 1. And if there is available space, it can be O of n in the worst case, if the array needs to be resized. In contrast, the linked list have O of 1 time complexity for insertion at the beginning or end, but can be less efficient in the middle due to the transversal. And for the searching, the array can be generally faster with O of n time complexity for an unsorted array, and O of log n for a sorted array using binary search. Linked list have O of n time complexity for searching since you have to transfer the list from the beginning. And while taking relation in regard, array can be O of n if the elemental location is not known, or as it might require shifting elements. While in linked list, it is usually O of 1 if you have a reference to the node you want to delete. So while in the category of array memory uses, array have a fixed size, so you must allocate memory for the maximum number of books you expect to store. So in this regard, linked lists are better as you can store any amount of book you can. And lastly, we're searching array is faster due to the time complexity of O of log of n time complexity if the array is sorted. While in linked list, it is O of n since you have to transfer the list. So for this matter searching, it is better to use array. So in the final conclusion, in overall experience for our purposes, the linked list is better for the comparison. Linked list is better in this regard for the data structure used. So we have make the use of linked list data structure. Thank you.